2016, I returned to Ghana with the vision of creating a media company. Along the line, the business did not really go as expected. And interestingly, my background in communication navigation during my MSc program in Germany helped me to create this drone company. And the journey has been great so far, where I adapted the use of drone technology for various applications: surveying and mapping, construction site monitoring, landfill monitoring, and other related applications. In the course of time, I have noticed or I've realized that the technology is evolving. And the bigger part of the problem related to the technology is that locally we do not have a lot of technical expertise when it comes to the practical side of the drone technology in terms of repair, maintenance, and even building these drones from scratch.
Unmanned area vehicles, popularly known as drone, is forever changing the traditional way of raw data analysis in the area of land survey, mapping, security and border patrol, and transportation from one point to the other. This drone technology, introduced by Soko Aerial, which is an end-to-end commercial enterprise, specializes in providing precision-acquired area inspection and survey data, process it, analyze and distribute the data to suit the needs of clients in their specific industry, has come in no better time, hence challenging the status quo.
We at Soko Aerial are striving to make a name for ourselves within the West African space as, if I should say, a pioneer in drone technology and provision of services. Most of the times we see that people buy drones, but then just keep their services at the photography and videography, as well as just the sales of the technology itself. We provide aerial data services for various industries. We talk of mining. We've done things in mining, farming, agric as a whole. We also have our hands, or let me say, we've dipped our fingers a bit into aerial photography and videography. Well, basically, it all comes down to the aerial photos and then videos. But then, what we do here is to focus on the kind of data we are extracting from these photos and videos. So in different industries, we provide different services. In the agric department or in the agric industry, we look at providing contour maps that will inform irrigation projects. In the mining industry, we also provide concession mapping as well as volumetric calculation.
Currently, all the interns are working on models in terms of training, and then some do research into the STEM-based projects that we want to roll out. We are currently working on an embedded systems programming course, which is geared towards learning how to program the flight controllers that we deal with when it comes to the drone build and design. And that will be tailored towards a new course that will roll out called the UAV Design and Build. Yes, they are. Some of them, this is not their field of expertise, but they are learning on the job as well. So I'd say they are doing quite well with where they are now. Yes, and there's room for improvement.
Soko Aerial, since the past 3 years, has been very instrumental with technology, undertaking various projects which span across various industries such as agriculture, building and construction, forestry, land and asset survey, security, among others. A very notable project Soko Aerial undertook in the year 2020 was the use of drone technology to assist in spraying and fumigation of chlorine-based bleach chemicals at market centers, lorry parks, schools, places of worship, police and military barracks as a contribution in the fight against the novel coronavirus outbreak in Ghana.
With the initial idea of just using the drone for service providing, we ventured into training and education with our partners, that is the Signal Training School. And along the line, we also saw the need to build a research lab to help foster research into education as well as building the drones locally to support our military. Soko Aerial has been an instrumental organization being part of the Ghana Armed Forces. And as I will say, one of our biggest achievements over the years is being part of the Land Combat Firepower exercise, where drones have been deployed in simulated operation environment. And this basically providing situation awareness on the battlefield for commanders and the command room to make decisions. And initially, these systems were not there. So for you to have a drone that can fly 15, 20 kilometers all the way to give a commander the situation on the ground, it was a game changer for the armed forces. Secondly, we also developed a RF-based radio tracking system which was deployed on the armored vehicles. And this enabled the military to know the location of all the various armored vehicles real time on the ground. And I will say that it has been a great learning curve where the military constantly feed us with great inputs in terms of how we can improve the technology we are developing for them to fit into their operational needs.
We offer training programs to both individuals and then the military as a whole.
I've known Soko area for the past 3 years, and then we've been involved in a number of projects. I first got to know the team from Soko area when we were tasked to provide surveillance and then aerial view from one of Ghana Armed Forces major operations, which is fire combat operations in Bondasi. So the firepower demonstration is conducted annually for Ghana Armed Forces to display its firepower to students, especially from the Ghana Armed Forces Command and Staff College.
Soko Aerial's passion for training the next generation for the full utilization of drone technology in Ghana and Africa has trained over 50 students since its inception in 2017. These students were tutored on programs such as transport networking, drone technology, forestry management, aviation safety, precision agriculture, sensor engineering, and artificial intelligence for a period of 6 months, and they were awarded with certification after individual project presentation and simulation exercises. Currently, Soko has 9 interns, which includes a JHS student and a preparatory pupil, undertaking various projects which are all at completion stages and can provide services to interested corporate institutions in Ghana and Africa.
As a unit, we work on hardware, software, and then we also provide technical solutions to our pilots on the field, the military, and also individuals. Currently, we have a project we are still working on, that is the GPS tracking system for drones. From the research I've made, I realized that a lot of pilots tend to lose their drones when sometimes they go to the field to fly them. Not because they are not good pilots or they don't have all the needed technical support or all that, but sometimes these things are bound to happen. And then one thing I also realized was that when you are flying your drone and your drone is to move out of sight or is to fall into a pit or a ditch somewhere, you begin running against time. And then once the drone power is down, you may not be able to recover your drone again. So with this onboard GPS system, it's independent on the drone's battery. So even if your drone is to go off, you can still have more battery time for you to recover the drone. The tracker comes with its receiver and then a desktop or a mobile application which works with it. So what you do is you first install the app either on your mobile phone or on your desktop application. Then you connect the application with your receiver. When you have the application with the receiver, you can now power on your tracker, which you've mounted onto the drone. Once you do that, you go through an authentication procedure which helps it connect with the receiver. And then immediately you begin sending the current location of your drone to the receiver. The mobile or the desktop application has a real-time map analysis feature, which helps you to view everything, view the orientation, view where exactly your drone, your tracker is. Whether you are using it on your drone or your vehicle, you are able to see that in real time with the application. We've done a variety of tests with this tracker, and then we keep on building on all the challenges we come across as we move on. So one current challenge we faced was, what if your drone is to move outside the range of the 6.6 kilometers? And what do you then do, since now you cannot have connection between your transmitter and then your receiver? So what we did as a team is that we included an onboard GSM model to the tracker, which helps you, the pilot, upon a request from your mobile phone, you send the current location of the tracker, and then you are able to go and recover your drone from there. And you don't also need to have any data or bundle plan. You don't need any Wi-Fi or internet access. The system is offline, and then it's applicable everywhere in every environment. Sometimes it's not always you fly your drone in the network coverage areas. So sometimes you fly outside these areas where there are no network coverage, and it becomes very difficult if we are dependent on these network coverage providers. So initially our plan was to make the whole system offline and then give the user the direct access to his data right from the drone. Currently, the tracker covers a radius range of 6.6 kilometers and has a battery life of 16 hours.
Every drone comes with software. We use software to control drones in order to make it easy for the pilot to control their drones. So I realized when you do a desktop app where individual can do a simulation, you have to test your drone first before you can apply all your parameters on the actual drone, so that when the drone crashes on your software, it doesn't affect or it doesn't do any harm to you. Someone asks, what's ground control station? So ground control station is basically a software and hardware based device used to control planes or drones. The already existing software allows us to visualize in 2D. I was able to integrate it into a 3D simulator so that users or the pilots can visualize it in a 3D form. The software is made up of two parts: the ground control software and 3D simulation environment. The ground control software is connected to the 3D simulation environment via software in the loop. The controller sends information to the ground control software for it to be sent to the 3D environment for the user or the student to have a better feel of the aircraft.
With global recognition of the growing importance of STEM education to be inculcated in the training manuals of all school-going children, Soko Aerial has also created a special purpose text soon to be rolled out to meet the growing demand of students in the field of STEM.
STEM is the abbreviation of 4 fields, that is science, technology, engineering, and mathematics. Before I moved into STEM, I was a general art student where I felt this is what I want to do. I want to be an engineer. So before I moved into STEM, people told me it was difficult, I couldn't do it, I can't be an engineer, I can't do this, I can't do that. But then I researched on it and I realized that it was easy to assess, it was easy to understand, it was easy to do. So I took it upon myself to go deep down into it. Here in Soko area, in the educational unit, our vision for it is to let the younger ones out there to know what STEM is about and then pilot drones, since that's what we do here. That's the robotics, where you learn how to analyze data, how to map, and how to survey as well. So I want to tell everybody out there who can join our STEM program, since it's not limited. We start from primary, JHS, SHS, and university. that is going to be very educative. And I want to encourage parents out there to please bring their younger ones also for internship and also join our STEM program since we are going to start in January. As part of our STEM program, we took in Telasi Kwame Yeboah, a JHS graduate, to take him through our program. And this is what he has become and this is what he can do.
My experience at Soko area is very useful for me because as a JHS graduate, I've learned so many things so far. I'm able to program hardwares to just do a specific function and also code programs that could also perform a specific function without the hardware. This is an home automated system which a user could access without a difficult pace. Some people, I would like to use a remote instead, but some people may ask, what if the remote gets missing? So in my point of view, whilst relaxing comfortably on your bed, you can embed the remote, embed it beside the drawer, beside the bed. So as is beside your bed, embedded beside your bed, you just click on a specific button and it will do this. So on the remote, I'll try to turn everything on. So everything here, it has told that everything here is on. So, and I'll try to turn on the fan. So now the fan is working now. And I'll try to turn it off. But the 7-segment display here tells that the fan is what? On. So as I turn on the fan, the dot over there turns on, which means that the fan is on. So when I click on off the fan, the dots there turns off, showing that the fan is turned off. And I can also try to use the gates to display the gates to just make fun a little. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Technology, when introduced at a tender age, has a tendency of improving the socioeconomic well-being of every country. These two young trainees, due to the shutdown of schools, took advantage of the pandemic to join Soko Aerial Training School to be trained on drone technology.
I am 11 years old. I attend school at 5 primary school. But because of the coronavirus, I came to Soko area to learn how to fly drones. But I also help them to pick up things like a screwdriver or a spanner. This is the work I have done since joining Soko area. The boat is called Prince Soko. But when you want it to go front.
Indeed, they make the use of drone tech fun and efficient in learning.
I'm also currently working on 3D printing a whole model aircraft. So for example, I'm working on 3D printing a model drone. But this is a work still in progress. So 3D print the parts and then we put them together. But the major project I've worked on since coming here was recycling broken propellers using 3D printed parts. At a point in time, we realized that we were losing a lot of propellers. Propellers got broken or bent while in flight due to wheel crashing or testing models. Most of our models were also belly landing. They land on their belly, and in that process we lose propellers. So what we basically did was design parts, 3D printed parts that can enable us convert our normal standard propeller into a folding propeller. This is an example of the folding propeller over here. So what this does is, while it's flying, when you stop the motor, it folds, the oil folds it backwards and gives it clearance and prevents it from getting into contact with the ground and breaking. Coming to Soko Aerial has been a very good thing for me because personally I'm a person who likes to learn new things. And over here, every day presents a challenge that enables me to build myself and learn new things. I see a lot more opportunities and areas to enter to build myself better.
Welcome to Soko Area Unmanned Area System Research Lab. We research into unmanned area systems. This is a startup to research into ways of locally producing unmanned area systems. We started work around June, and along the road there have been a lot of models, but these are some of the significant ones that we have. Our flagship, let me say, was the Intern model. That was the very first model that had a fully controlled successful flight. It had 1.8 wingspan, about 1.2 fuselage length, powered by 3-cell LiPo battery, and then we have an Emax motor giving us about 700 grams of thrust. It was around 21st August. It was on a Friday, fantastic one. We had our first test flight, and it was so beautiful. So from there, we've taken it to some few places to test it in conjunction with the Signal Regiment. We are still working on it to make it a platform for FPV setup. So we are trying to get our electronic systems so that our cameras and things will be installed, and then more will be tested. Now that we also have our foldable props, we hope to get more trust and more activity from it. Then one thing we also came up with as a research lab is that we shall need a utility aircraft that can be used to test some of our components. If we have payload systems such as cameras, gimbals, or other things to test, we can use this aircraft to fly it to altitude and then test its performance, the altitude, the range, the endurance, and everything. If it also happens that we'll make smaller models, gliders, we can also put them externally, fly this up to altitude, and then to test its performance. This is a street copy of the Airbus A400M military transport aircraft. We have not tested it yet, so the engines will be here, 4 of them, and then we configure it for flight. This will be done very soon. Then we have our double dihedral watcher, and as you can see, it has an H-tail, double rudder. Wingspan is about 2 meters, fuselage length about 1.3 meters. It has gone to the first maiden flight, very successful. We know that we'll see that in the videos to come. Also powered by this A2212 1000 kilovolts motor, giving us about 600 grams of thrust. It has been done before. Then we have our largest model so far. This is a straight copy of the US Air Force Global Hawk surveillance platform. The reason why we came out with this was that at some point the electronic components we had could only be supported by a very large aircraft. What I mean is that our battery was a 1.8 kilogram 6 volts 16,000 milliampere battery, very heavy. And then we had 2 EDFs, 6-cell EDFs, giving us a thrust of about 2.8 per motor. So the 2 of them combined, that's about 4.6 kilograms of thrust. And so we had to come up with this model, and we chose this because we have the V-tail at the back. That gives us a smaller tail size or tail volume, and that reduces drag, aerodynamic drag in flight. So wingspan is about 2.9, almost 3 meters. We've done the ground testing, everything was successful. During the very first attempted takeoff, the front gear had a little issue, and we are still working on it. We want to also change the tires to much bigger ones so that to have a much faster takeoff room. This small aircraft at the back here too is intended as a trainer for the department and anybody who may visit in the future. So pilot training will take off on this, will be done on this. It has very high dihedral angle, 5 degrees on each side, very light, and to be powered by one of the Emax motors. With very little thrust, it will take off, and it will have very good handling performance. So this will be one of our major trainers And we know we have just begun the work, so in the near future to come, we would like to have, or we will hope to have more models and much more high performance.
I think Soko area is contributing so much to security in general because they are creating the awareness of the importance of including or integrating the use of UAVs into military operations and security operations in general. So during the COVID season, when COVID was at its peak in Ghana, they played a very vital role. They were very instrumental in carrying out and spraying of areas that were thought to be highly infected. They brought in a bit of using drones instead of going manually or the traditional way. That's a good contribution. And then they've created awareness, so now everybody within the security sector is looking at how to integrate drones into its operation. So I think they are making a good contribution.
Soko Aerial's partnership with the Signals Training Department of Ghana Army has yielded great benefit for both parties to develop and deliver high-level technological equipment to boost security deployment.
We have a standing partnership with the military that has given us an environment to provide both military personnel as well as those from the civil side with basic training on how to pilot the drones as well as how to analyze and process data collected with these drones. Now, going forward, our partnership has come to include the setting up of a lab, a research lab, where we're working in tandem with the military to churn out various drone data collection products, and also looking into how to build our own drones down here.
The idea was to be able to live stream whatever each component was doing on the battlefield, and then to project these visuals to an operations room so that those at the operation rooms, including commanders, could have clear visualization of whatever was happening on the battlefield. So we did that and it was very successful. And for the past 3 years, each year we are invited to provide the same services.
It's been about 2 years since we started this journey with the military, and they've been very supportive in terms of the various innovation and innovative projects. This year, the lab was officially opened and we've been able to build a couple of interesting models. And also, we've also created the Communication and Defense Lab, where we've worked on various communication technologies to help drone technology in the area of searching for missing drones.
With all these successes chalked came with 8 key challenges as a young growing company.
I would not say drone is 100% the game changer, but drone is a huge enhancement or a huge advantage to our security agencies in terms of surveillance, search and rescue, border patrol, and all kinds of related covert operations. Drones do the dirty work, which helps to prevent unnecessary human input. And as I said earlier on, it is important to make sure that everybody comes back home safely. So if a technology like a drone can help us do that, why not? But we should also not forget that it's a human being that will put in the operations.
Teamwork is one success story Soko Area Robotic Company can easily be identified with due to a highly motivating environment curated by the CEO, Kofi Owusu-Edusei, who believes in impacting positively and capacity building through teamwork and happy hour.
Like our motto says, Soko Aerial Imaging in Africa, we are looking at becoming one of the pioneers. And if not only one of the pioneers, but then one that has a very strong footing within the West African sub-region, as well as Africa as a whole.
In the next 5 years, I see Soko being the leader in terms of drone technology, not just in Africa, but across the sub-region. So in the next 5 years, it will be a force to be reckoned with.
So in 5 years' time, I want to see myself as a big programmer and a good doctor one day.
Soko area is a very promising organization, and I look forward to seeing them as major players in the defense industry. I think with a little effort, they can reach that height.
Soko area as a company, we are focused on building the technical expertise needed to keep this industry alive. I may not want to sound negative, but this technology is completely imported. Of course, we have some bit of understanding on its usage, but the question we need to ask ourselves is that, what is the long-term goal? How do we want to sustain it? Are the current generation of engineers or young guys ready to take up such technologies and advance it? Or are we just going to place ourselves in a position to just use it?